The purpose of this video is for you to be able to name compounds with polyatomic ions. And polyatomic ion is when you got like two nonmetals that are covalently bonded and they have an overall charge. So two nonmetals from this area, okay? And they're covalently bonded, so they're sharing the electrons, but they still have an overall charge. Some examples of these, when you're going to see them in formulas: hydroxide, OH negative, sulfate, SO2, SO4 negative 2, and nitrate, NO3 negative 1. So you've got the two nonmetals, the nitrogen, the oxygen, the sulfur, and the oxygen, and they have an overall charge. And we're learning how when they're in a formula, what's the name? Now, it's basically the same format as other formulas, like where you've got to just kind of read it. The only exception is, excuse me, not exception, but the only specific rule is that with polyatomic ions, their names don't change. So I don't change anything to "ide," or I don't need a Roman numeral because their charges are set. I just read the polyatomic ions in place, and that's the name. For example, this is the polyatomic ion ammonium, and OH is hydroxide. All right? Now, to do these, you're going to need to remember the charges of things. Group 1 is +1, group 2 is +2. The ones in the middle, transition metals, and the ones to the left or to the right of that section on the periodic table, their charges really are dependent on what they're bonding with, and the way to know is by going by the anion and backtracking, so to speak. So, for example, barium. Barium is in group 2, so barium's charge is always +2. So this one would be barium hydroxide. Here's my polyatomic ion, the OH, that's hydroxide. Barium is Ba. Now, Zn, SO4. This is my polyatomic ion, that's sulfate. Zinc is right smack in the middle. I think it's group, not smack, I think it's like group 12, element 30. Zinc is a transition metal, so its charge may vary. I got to go by the anion. Sulfate's charge is -2. I would know that by looking up the charges of on a sheet of all the polyatomic ions. Sulfate, therefore, has a -2 charge. There's one of them, so that means that the zinc has to have a +2 charge. So this is zinc 2 sulfate. All right, one last example. Where's my polyatomic ion? It's this thing right here. This is phosphate. And phosphate has a charge of -3. So how many of them do I have? And I have 2. So I have 2 -3s. Now I can solve this in 2 ways. I can draw the picture. I can do it mentally, math in my head, like the charges, making sure that they neutralize. I'm going to go with a picture because I like visuals. PO4, -3. PO4, -3. That's so funny. And then I've got 3 CRs, CR, CR, CR. -3 and -3 make -6. And then I have 3 of them. I divide 6 by 2 and I get +2. So the charge on the chromium is 2 So this is chromium 2 phosphate. All right, just to recap, the names of the polyatomic ions don't change. All other rules stay the same. Roman numerals for the ones that need it, these people in here. And you always go with a cation, anion in the name of the formula. And